All right, everybody. So in this video, we're going to pick up where we left off in my last video, which was talking about univariate visualizations. And in this one, we're going to start to tackle bivariate visualizations. So we're going to jump into my R screen and we'll get right at it. All right, so in this video, we're just gonna pick up where I left off in the last video, but a few important points are that you're going to need to load in the heights_long data set, which is linked. And you're also going to want to make sure that you've got a few packages installed and you've used the library command to load them up. Now those packages are going to be the tidyverse, scatterplot, and flexplot. Now, if you don't know how to install those, make sure you watch the Univariate visualizations video and get right to it. Now, once you've got those loaded up, we can get going on doing some bivariate visualizations. So let's get into those. So in the flexplot package, there's a few data sets that we're going to be accessing. So once you've got the flexplot package loaded up, we're going to be able to access a few of those that are included. So for example, one of them is called exercise data. So I can just use the view command, view exercise data, and you can see here it's shown me that exists, exercise data, and it's in the package flexplot. And it's given me a little bit of a preview of that, but I want to use my tab function to fill that out. And I'm going to run that command and it shows me my exercise data set. And we can see here that it's got a therapy.type, and there's cognitive, behavioral, and control, some value for health, motivation, weight loss, etc. So this data set, we can go through and we can do a lot of visualization of these different variables. So I'm going to go back to my script file. And the first thing we're going to do is we're going to say, let's have a look at weight loss as a function of motivation. So basically asking, does motivation have some kind of effect on our weight loss that we experience following an exercise program? So the first thing we may want to do is, like I showed in the previous video, is look at our univariate distributions to see if there's any potential massive problems in our data. So I'm going to use the command flexplot weight.loss as a function of 1. Remember, this will give us a histogram, and then data equals, and I can just start typing exercise data, hit tab to finish it, and run that command. Now what we see is in the graph below me, it's provided a histogram of weight loss, and it doesn't look like there's any major problems. Data's a little bit skewed, negatively skewed because it goes out towards the negative direction, but it's not too bad at all. So I don't see any problems with this data to start. So the next thing we might want to do is say, okay, that's great. The other variable I'm going to look at is motivation. So I'm going to copy and paste that command and then just fill this in with motivation instead. Now, I look at that. Again, I get a histogram. I don't see any major problems with it. Looks like my motivation ranges from about 20 up to 80. Okay, so now we get to where we want. I'm going to, again, copy this command because I don't want to type it out each time, especially me. I make mistakes all the time. So I'm going to do, that's actually not the one that I want. I want weight loss as a function of motivation. So I'm going to copy that top one, go weight loss, and I'm going to replace 1 with, in fact, you can double click on one of these variable names and it highlights the whole thing. So I'm going to double click that, copy, and just paste it in place of the 1. That makes my life a lot easier. Now we see this gives us what's called a scatter plot. And we've got motivation on the x-axis and we've got weight loss on the y-axis. So we can see that it looks like as motivation goes up, our weight loss increases. And that's what that blue line is showing us. Now, by default, flexplot actually gives us what's called a lowest line. And the lowest line is, you can imagine it as being sort of like a moving average regression line. So it just will bend with the data, and this allows us to see any curvilinearity in the data. We can see maybe it drops down a little bit at the beginning and pops up a little bit at the end, but we're not going to worry about that too much. That might indicate that we have some nonlinear function in our data, but we're not going to worry about that right now. And imagine, okay, well, if we wanted to just plot a straight line through that instead of using the default lowest line, we can use the same command, except we just use an extra argument on the end, where basically it is called method equals, in quotes, LM. And LM means linear model. Now, if I do that, what we see is it puts a straight line all the way through my data. And this allows us to see that there appears to be a reasonably consistent trend where increased motivation leads to increase in weight loss. Now, we've also got a lot of flexibility over what we wanted to plot. So I could tell it, for example, I'll copy and paste that line, that SE equals F. What that does is that gets rid of the bars that showed us the standard error of the mean of our regression line. Don't need to worry about that too much right now. Or I could tell it raw.data equals F. Now it gets rid of the raw data. And of course, I could do both of those if I like. So there's just a lot of flexibility in graphing what we want using flexplot. All right, so let's imagine now we want to plot a numeric variable as a function of a category. So we can use our heights data to look at that. So we've got heights as a function of sex. So when we do that, we type flexplot height as a function of sex, where data equals heights underscore long. Now, by default, what it does is it gives us a graph that looks like what you see below. And what this is the red dot represents the median, the two whiskers, the upper and lower quartiles. So this is the third quartile, this is the fourth or bottom quartile. And then it also plots the raw data. And this is for males and for females. So we can really see a lot of information all at the same time. So this is the default way that flexplot will plot numeric on categorical data. And it's really nice because this really gives you a good overview of what your data looks like. It'd be really easy to see outliers and all kinds of other things. You could plot that in different ways. So I'm going to copy this. And instead, if you didn't want it to be plotting the standard method using medians and quartiles, you could tell it to use a different type of spread. So spread equals STERR. Now, if I run that command, we can see that I've got the mean and the standard error of the mean instead of the median and the quartiles. Similarly, if I wanted to copy that command and I wanted to use STDEV, this will give me the mean and the standard deviation instead. And we can see that it's the same data, but it's just got the standard deviation instead. And if you want to finally do the same thing, in fact, I'll just add it to this. I can tell it raw.data equals false, and it'll just remove the raw data. So again, like I said, this shows you that you've got a lot of flexibility in flexplot for you to be able to do what you want. You could similarly create box plots, but it doesn't really give you any other information over and above what the default flexplot function gives you by using the median and the quartiles. Now, in the previous video, I showed you how we might want to identify some outliers or problems in our data using univariate visualization. But we could do the same thing using a bivariate visualization. So let's have a quick example here. Now, I haven't provided this data, but it's just to give you an idea of what I'm talking about. So if I use the command flexplot, muscle gain as a function of intervention, comma, data equals muscle, I believe. Yes. That should give me this graph of our data where we see both of the issues here that we had at the same time previously. So we can see that in the protein group down here, we appear to have one outlier that's really high above the rest of the data. Not only that, we can see that we seem to have this workout group here where we thought we'd only have exercise and protein. So that might be something we might need to look at. So if we graph this, all of a sudden we'd be able to identify very quickly that we may have a problem with outliers and possibly some mislabeled data in there as well. So we can look at another example of doing bivariate data using the Avengers dataset that's included in the flexplot package. So if I just type the command flexplot, and we're going to look at PTSD as a function of the battlefield that the final Avengers battle took place on. So the variable is called north_south. And I need to specify the data equals Avengers. Now, what we can see is there's a lot of data points here. So we've got a south battlefield and a north battlefield. Looks like there's a couple of outliers, nothing too bad. We've got reasonably normally distributed data. We can see that just sort of by the number of data points that are shown in every part of this graph. So it looks pretty good, although it's a little bit busy with the number of dots. It's really difficult to really get a good grasp of what we want to see. So one way we could actually take a look at this a little bit differently is we can change the number of data points that are plotted on the graph. Instead of plotting all of them, I could just randomly sample some of them. So I can say sample equals 50, and that'll give me a total sample of 50 for the entire figure. So I plot that, and we can see, look, it's given me 50 random data points. I could plot it again. It gives me a different random 50. Although note that the mean or median and the quartiles don't change at all. The sample is only just changing which data points, the raw data points, are plotted on the graph. If I wanted to plot 150, it'll give me a few more. It makes it a little bit easier to see maybe the distribution. But I just wanted to show you that you can change the number of data points that are plotted pretty simply and pretty quickly. If you wanted to say instead raw data equals false, that would just plot 0 points. Now remember, there's two main reasons why we're going to visualize our data. The first is we want to determine whether there's some problems with our data, maybe outliers or nonsensical data points or problems with labeling, things like that. But it also allows us to really easily characterize our data. So as an example, if I use the library that we've used previously called psych, it's attaching the package psych. I've loaded that up. If you haven't got it installed, you might want to install the package psych. And I'm going to describe some data that's included in the flexplot package. So I'm going to use the describe by function that's in the psych package. And note that the structure of this argument, or all the arguments that go within this command, is exactly the same as what's in flexplot. So I'm going to say in the graduate income, I want to look at income as a function of profession. Now, of course, I didn't know that income and profession are included in that data set. If I wanted to, I could very quickly view that data set. I'm going to type capital view, and it was called graduate income, right? Right. If I view that data set, we can see that there's grad.school, profession, years, GPA, and income. And what I'm doing is I'm describing income as a function of profession. Data equals graduate income. Now, if I describe that, what we see is I get a big table of data. I've got a mean and a standard deviation and medians, all this stuff. This is great. And sometimes you might even see this presented this way in scientific papers. But instead of presenting all of this data, it just seems a lot simpler to be able to use the same command and use flexplot. And now when I run that, I can very, very quickly see the data and I can understand it very easily. So we can see not only do I have only a few data points for my professor group, I've got a lot of data points for my other group. They seem to be distributed quite normally. I can identify what their means are or their medians here and the quartiles. This allows me to see whether or not there's any skew in the data or any problems with the data. So this is just a much more easy way for us as humans to be able to understand our data. And of course, if we identified any problems, we could look at these variables individually using univariate visualizations, or we could panel them, or all kinds of different things. All right, so hopefully that's given you a good idea of how to get started with doing some bivariate visualizations to be able to look at scatter plots, which are involving two numeric variables plotted against each other, or what we call these B-swarm plots, which is basically a numeric variable plotted as a function of some category. All right, so in the next video, we're going to look at a few of the common issues and errors that might come up in R, and some of the examples that I use involve the plotting functions that we've used today. So if you are wondering about some of the errors that you might encounter in R, watch that video next.